So, just to let you know what's going to be happening then. So, we are going to carry on and we're going to get algebraic fractions finished, okay, which is good. We started that at the end of last term and we talked a lot about numeric fractions. And so what we need, and we did start with the algebraic fractions, didn't we? So we need to recap on that. To explain what's going to happen in terms of your exam and that kind of thing. So you've got your exam coming up, all right? You took your practice one beforehand?
Yeah.
Before the break?
Did we get
You got that back?
Yeah, we marked it. What practice?
Yeah.
The one that everyone did.
So that.
Oh, I got 29 out of 54.
Yeah. So that was that gave you an idea about whether you needed to improve on that topic. The exam will basically. I've got this sheet to give. Yours isn't in colour because colour one wasn't working. But this is the material in yellow. Yours will be in grey. Of what we've covered so far. All right. Actually, the first bit that's in white is stuff that I've been told you did in year 9.
Addition and subtraction.
So that's surds. Okay. Now, what I'm going to give you, so I'm going to give you this in a bit, all right? So it tells you what to expect in the exam. So what's going to happen is I'm going to write the first part of the first exam, which will be common between you guys and the top set. But it's only going to be the stuff that we've done because basically they have done different to us. Not more, different. Okay, so they skipped, I think, something we just did, and they went straight on to trigonometry. We're following the scheme of work as it is. So that's why we're going to have the first 45 minutes where we'll all have the same stuff, but then afterwards you'll have a section that's just related to you and what you've done, and then the second paper will be I think the calculator bit will be just you guys as well, just what we've studied together. All right, make sense? What I'm going to do as well, and I need to go photocopy this for you, I'm going to give you your first start of the paper 6 for homework. All right, I've got to go and photo this. Only the section A, so this is for Cambridge, the third paper. All right, where it's an investigational paper. It's investigation and modelling. Now, you might look at this first time round and go, I haven't got a clue what to do. You haven't taught us how to do this. What I do with these is I give them to you, get to fun, because you can't really revise specifically for a paper 6. It's about following a process, so you just have to go and do it, and then when you bring it back in, we'll go through it together rather than me just mark it to start with. And the more you do, the easier they'll become. So I'm going to give you that today. All right. So that's basically how it goes. So also in terms of revision, I think you have about 8 lessons until your exams start, maths lessons.
So in those lessons, are we learning more?
Yeah, so we will be doing for at least the next 4, we're going to carry on with the scheme work. Right? Just like top set, they're going to carry on doing their logarithms and things at least till the middle of next week. And then I will be giving you a full cycle, so 4 lessons, and we'll revise. We'll go through some revision. I'll maybe give you some practice past paper questions, things like that for homework and stuff. But then in that time, I won't give you any other homework either. It will just be your preparation time. All right? So that's the way it's going to go. Happy with that? Okay. Right, so let's have a look at algebraic fractions then. Do you want to get your textbooks? Okay. Oh, sorry. Page 341, not 334. Something else. Right, so we've already started with this. We're going to talk about simplifying algebraic fractions. We've also got to multiply them, add them, subtract them. Now you know how to do it with numbers. Okay, we've got to remember exactly what we do with numbers we're going to do with algebra, because algebra is just unknown numbers. All right. So just as a recap, all right. So if I said to you, simplify a squared b over ab squared.
So
It would be right now in like A and
oh,
If you like, yeah. So what would it be?
Wouldn't it be AB?
yeah.
So the top row, if you wanted to write it all out, would be a times b, and this would be a times b times b.
So and then you cancel.
Okay, now what was important, wasn't it, that we don't just we don't disappear them. We're not like mafia, just disappearing people. All right, we're saying that something divided by itself is the same as 1. So b times b over b can be replaced by a times 1, and timesing by 1 is the same as doing nothing. Okay, right? So we can cross them out as long as we understand it's now replaced by a times 1 that we're not bothering to write.
If we do write it, do we have to put ones where both of them are, or just
Well, if I put a 1 over 1, isn't that just the same as 1? Okay. And then the same, this a over a could also be replaced by a 1. Okay. That leaves me with just a over b. So it's simplified. All right. Do you remember that?
yeah.
Okay. So just to check then, if I said simplify a plus b over a minus c, b over minus c.
So we're just doing these. No, it's not.
Go on. Congratulations. Well done. Perfect. Right, it's not, we can't cancel the a over the a because it's only when it's all multiplied. We've got a plus b and it's a minus c. So this one, we'd have to say cannot be simplified. Well done. Okay. All coming back to you now. Yeah. Right. So we then had a look at question 2, was just about saying, well, sometimes the answer in the back of the book is slightly different to the answer you've got, but are they equivalent or not? So in this question, for question 2, let's have a look at 3a plus 6b is all over 3. Okay. So with question 2 it says split the expression into 2 parts and then simplify. So what does that mean?
So 3a over 3 and b over 3.
That's a 6. 6 Okay?
So what does the answer be? A plus 2.
So then 3 over 3 simplifies to just
A.
a, and then
2b.
2b. Yeah.
So I was correct.
Now, just to show you, the 3, therefore, if you don't want to split the middle term, another shortcut, as long as you understand what you're actually doing, is if it's on the bottom and you've got a plus on top, as long as you can cancel it from both parts, it's okay. So the 3 and the 3 cancelled to make a 1 and a 1, but the 3 also has to cancel with the 6, which would make a 2. Okay? So it has to be able to cancel with both parts if there's a plus or a minus. that make sense? Or?
Yeah.
Okay.
That makes sense.
If it doesn't do with, but so for instance, let me just show you an example of when. So if I had, for instance, 3a plus 2b over 3, what's different about that now? So the 3 goes in the 3, but the 3 doesn't go in the 2, therefore I can't simplify. However, I could write in another form. For instance, if I split the middle term, not split the middle term, split them and say 3a over 3 plus 2b over 3, what would then, could I then do anything with that? So this would be a plus 2b over 3. So to show you that this and this are equivalent answers, they're equivalent, but they're not necessarily any simpler. So you've not simplified anything. So this is why I'm saying you may well at some point come up with that answer, the second one, in your book, and the answer in the back of the book looks like that. As long as you don't mark yourself wrong, you need to say, oh, are they the same? Yeah, they're the same. Okay? So this is all recapping very quickly. Let's move very quickly on to question 4 then. So for instance, let's do x plus 2 times x plus 5. What does that look like, by the way? That is a
Quadratic.
It's a quadratic in what form?
Brackets.
What's that called? Beginning with an F.
Foil.
That's what you would use to factorize. This is the factorized form. Now don't forget, when you simplify fractions, you find a common factor. So even if we have a quadratic one, if we have a quadratic fraction, we want it in factorized form, because then it's all about, can you take a common factor out?
Yes.
And what's the common factor?
X plus 5.
X plus 5. So we can cancel the x plus 5s, because those would be, even if we don't know what x is, x plus 5 divided by x plus 5 will be 1. Whatever x is, yeah? If you divide something by itself, the answer will always be 1. So what are we left with?
X plus 2 over 5.
Over 5. Okay. Right, I think, correct me if I'm wrong, I think we already spent some time working up to that sort of level.
Yeah.
Yeah? So what we could probably look at is, if you look at page 343, where you actually have to do the factorising before you simplify. Or would you like a couple of moments to have another couple of practices on question 4?
Yes. Question 4. Just for the extra practice.
Well, I don't want to spend too long on it, because obviously we're running out of lessons.
We could continue.
Alright, okay. Let's have a look then. Let's have a look at exercise 16A.2, page 343. And what we are doing is factorise before simplification. Okay. So to write our notes, so you can only cancel common factors. So it's all about factors. You have to have factors. You know, like was said, if it's just something plus something, you can't simplify it. So we have to have something times something to be able to. Because it makes sense, doesn't it, that if you times by 1, does nothing. but if you add 1, it changes it, doesn't it? So it makes sense that we're looking to replace common factors by a times by 1. All right. So let's have a look at their examples. So we've got 4a plus 8 all over 4. So I think we've probably already got skills to be able to do this one. We were just talking about it before.
A plus 2.
So if we factorise the top, what do we get? 4a plus 2 all over 4. Okay?
We cancel out 4s.
And the 4s are the common factor. Now if I like, I can consider it as 4 times 1. So then the 4 and the 4, so we're left with a plus 2 over 1, but we don't really write an over 1, do we? So we're just left with a plus 2.
So do we have to change it?
Say that again?
Oh no.
She said, do you have to change it? Like, do you have to factorize?
Right, well, that's a good question. Do we have to factorise? So, for instance, you'll get to the stage where we'll say, actually, do you remember I was just talking about? The 4 is in the 4 and the 8.
Yeah.
So you could just do 4, well, that becomes a 1. 4 with the 8 becomes the 2. So we've got a plus 2. So that's another way of doing it. The other way of doing it was splitting it like we did before. So 4a over 4 plus 8 over 4. 4a over 4 becomes just a. 8 over 4 becomes 2. So you pick whichever method works for you, as long as you understand what's going on. Right?
So you have to see how many ones you do.
Again, if you're going to use this method where you cancel, you remember, you've got to be able to cancel from both parts. Now, it might even be that there's a third part, like a 4a plus 6b plus, and it has to be out of all 3, not just 2 of them. Okay. Right. We're going to have a look at example 4 and 5 very quickly. So, example 4, I haven't done B. You can have a look at B yourself. We're on page 342, by the way. We've got AB minus AC all over B minus C. Okay? So we've got to simplify that.
But it's not being.
It's not because it's not being multiplied.
So this
But is there any way of factorising the top?
A squared.
It's a just
Exactly. A, so there's an A and an A, so the A is obviously the common factor up here. So A brackets
B minus C.
B minus C. And the clue is there's a B minus C on the bottom. So just
That's
so
not
we'll
right. I can't be right answer, man.
okay. So the clue is in the question as well. There's a B minus C on the as the denominator. That's probably the common factor that you're going to be looking for in the top. All right, gives you a clue, gives you a starting point at least. All right, and then 2x squared minus 4x all over 4x minus 8. So what do you think? We're probably going to have to factorise both. And we're going to have to find a common factor.
So the common factor is 2.
So it looks like the biggest factor out here. So I remember I was chatting probably in my year 7s about factorising and the difference between fully factorising and just factorising. Do you know the difference?
Fully is making sure that everything has been simplified.
Yeah, see, well, not simplified.
Right.
Fully factorising is when you take the highest common factor out. Okay? But sometimes you don't need to fully factorise. So for instance, this is a good example of one of those. if I fully factorise the top, what do I get?
Oh, you get 2x
So 2x,
bracket x minus 2.
okay. Right. Which it does work. But what do we get if we now factorise the bottom?
4. 4. And then we got 4.
4,
X. And then x minus 2.
okay. So what do we end up with?
2x and 2x over 4.
Is that what you'd finish with?
No, because it'll just be
You could do x over 2.
X over 2, good.
I see.
Okay. Now, just to check, if for this happens quite often, so for instance, a question like that, what someone might do is go 2 times x squared minus 2x, and they would do this as 4 and x minus 2. So it's not fully factorised. And what happens then? What do people do? Well, we can still do the 2 and the 4, because it becomes, so I've got x squared minus 2x over 2 times x minus 2. So I've cancelled the 4 with the 2, so it's a 1 and a 2. Okay? So we've kind of, because we've only partially factorised, we've only partially simplified the fraction. So this one could go even further, couldn't it? Yeah?
You could divide, no, you could divide x
Oh, we've got-
by x, so you
yeah.
just have x and then divide by,
Yeah, so we've got to keep factorising to get the x minus 2 on top, and then we've got the 2 and x minus, and then we cancel out the x minus 2. So that's where not fully factorising can lead you to not fully simplify. Okay? One more before I let you get on then. Stop me if you want to write down everything I'm writing and you've not got time. Going to have a look at example 5, part B. So AB squared minus AB all over 1 minus B. So again, the clue is in the denominator, this case.
So then
So we've got 1 minus B. 1 minus B doesn't factorise. But what about factorise?
B is B.
Oh, it'll be 1 minus b and then ab on the
Oh,
outside.
well. Okay, well, let's be careful here. Factorise the top. What do we actually get?
A,
So it's AB.
B bracket
B minus.
b minus 1.
Okay.
That's what happens at the other one, right?
Can't you just flip it?
No, because that doesn't mean the same thing.
Good point. Doesn't mean the same thing. So we can do something about this. We have talked about this in a different context about the way to deal with this. So can b minus 1 cancel with 1 minus b?
Not necessarily. Can you make it positive?
Who said that?
Thanks.
Congratulations. So let's just, I'll write this note here. Can't be cancelled like this. Because b minus 1 is not the same as 1 minus b. However, Lucy said something very smart, which is we can multiply by minus 1, which changes the signs, doesn't it? And which one would I multiply by minus 1? The bottom. Okay, so I'm going to keep AB and B minus 1 up the top, but underneath, what do I then write? minus 1 bracket 1 minus b, if you like, which we then deal with in what way? So this is, we've timed by minus 1 to do that. So then I can sort this bracket out. So I've got AB still B minus 1. What does multiplying by minus 1 do to that? It makes it minus 1 and plus B.
Which is the same as the
Which is the same as B minus 1.
Good job,
Yeah.
everybody.
So I can do that. So now, although they look different, they're the same. So now we can cancel those two. So we get the answer AB. Now again, in an exam, if they give you a question like that, if you didn't remember that whole being able to do that, then you're going to get stuck at that point. What do you think they would do if they were marking your paper and your solution looked like this? So if I did AB and I've got B minus 1 and I've got 1 minus B and I cancelled out and I get the answer AB, which is the correct answer, what do you think is going to happen?
They would put a little sign in.
Wouldn't it be a follow through
Doug, you gotta roll it.
They're wrong.
Because that was a guess.
Because even if your answer is correct, it's a mistake that led to it getting the correct. Normally what they would try to do is write questions where that's not a possibility. Sometimes it happens. But if you do that, okay, they wouldn't mark this correct. It would be, you must check the working. As an examiner, if I'm marking your work, if I'm marking your actual IGCSE, I'd have to see that. And it would probably say in the question, must show you working, and there wouldn't be any marks if I didn't see you working. And then if I saw your working and you made that mistake, because you're not allowed to cancel B minus 1 with 1 minus B. Okay.
So, like.
Actually, are we correct here?
In the book it's
Okay. Because obviously the answer shouldn't be the same. So we've missed something out here. There's something actually, I mean, I forgot to do. Yeah, exactly. Do you remember, if I multiply by minus 1 here, to keep it the same, I have to multiply by minus 1 at the top too. So the correct answer should be minus AB. And that's
But
that.
even if you don't do that, couldn't you do, you would still get minus AB, because we have 500 to get 1 to get minus 1.
Yes. Exactly the same idea. You'd still make the mistake. All right. Okay. So just that was something to consider. Now, without wanting to give you too much more, obviously, you need to factorize linear equations like this. You need to be able to do that. But you're also going to have to factorize quadratics. So if you think back to the one we went through here, obviously if that's an option for cancelling, then you're going to have to get to that point. You're going to have to be able to factorise a quadratic. You still remember how to do that?
Yes.
Yeah.
It's right
Okay.
here.
Well, I'm not going to go any further. I'm going to say to you, looking at exercise 16A.2, you've got questions 1, 2 and 3, right? And 4. Questions 1, 2, 3 and 4. Again, remember we've looked at questions before, and one thing I've asked you to do is look through the whole A, B, C, D, E, F, that part of the question. Notice where they make a slight change to the question. They're not all exactly the same, they change in a subtle way. And make sure that you've covered each one of those changes. So you don't have to do every question, but make sure you've covered all the different options. And then you can work your way through. That make sense? So you can do a range of questions from question 1, 2, 3 and 4, but make sure you've covered any change that they've made. So it might just be all of A, B and C are plus, D, E, F have minuses in them, and so on. Okay? Right, I'll let you work and ask for help when you need.